Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we're going to be looking at some PC motherboards. I have a 386DX motherboard here that's had a battery leak. I don't know if it's working. It's given to me in an unknown state. And there's a 286 motherboard that's also in unknown state and has had battery leakage. Will either of these motherboards work? Let's find out. And if they don't, let's try to fix them. So without further ado, let's get right to it. First, let's take a look at this 386DX motherboard. It's an interesting motherboard because I don't think I've ever seen a 386 motherboard that had quite so much RAM on it that was DIP memory like this. The motherboard shape is actually what's just called an AT motherboard. It's similar or the same size as the original IBM 5170 motherboard, the 286 in that computer. Later motherboards where the keyboard connector was on the far right edge were called Baby AT. And that's what came later. In a lot of cases only support Baby AT. But earlier cases like the original 5170, and there are some other desktop and tower cases, do support this full-size AT motherboard. Judging by date codes that I see on these chips, looks like 1989. That's on the BIOS here. And that's 88, 88, 89, 89. So obviously from around 1989. There's a 16 megahertz 386DX processor, spot for a math coprocessor, Chips and Technology chipsets, one of the early ones, and there is all that glorious DIP memory. Look at all that. It just goes on and on and on. Looking at the part number on here, we have 41C1000AP-8, so 80 nanosecond RAM. I don't know if the date code is 94 third week, maybe, maybe not. Obviously we have Samsung memory here. There does appear to be 18 chips in each row here. So 8 of these would be 1 megabyte, and there's another 8, and then we have 2 extra chips for parity, which means that this is 2 megs, 4 megs, 6 megs, and 8 megabytes of RAM in DIP memory on this thing. And then notice that this slot has this extra length to it, and I'm going to imagine that this has the extra 16 bits of data path required to add a RAM expansion card into this motherboard to go even beyond this memory. Take a look next to the RAM chips though. You see there's extra pins there? That's because if you take out these chips, you can actually put 256K chips in as well, and they'll be offset. They have one less row of pins. And if you did that, you'd have 256K 512, 1 meg with these 2 rows, and 2 megabytes with all 4 populated, plus the parity memory. So with 2 megabytes in there, then you might want to use this card here to extend the capacity. I don't actually have this card, and I'm not sure how standard that is from one manufacturer to another. And as is super common with 386s, there was a NiCad or nickel metal hydride battery right here for the CMOS, and it leaked. The previous owner did remove it, so it's cut off, but unfortunately, the leaking actually did do some damage. I'm looking in the viewfinder screen, it's very hard to tell, but some of these traces here may actually be damaged, and there was actually quite a lot of green crusties on this board around these components here, and I did scrape it away, but you can tell, look at that solder, that joint there, that is not shiny, that is dull, because that is corroded, and actually check out this ISA slot here. You can see the green crusties made their way inside there and there. And even though I put some vinegar on here, let it soak a little while, scrubbed it with a brush, and then I used my tweezers to scrape away at all the crusties and then put some IPA on here, I have no idea if this board is going to work. Looking in this area to see what kind of damage might have happened from this leaky battery, well, I'm not sure what this chip does here, but clearly if the corrosion is underneath there and any traces of this are eaten, that's probably going to have some significant functionality problems. These are 74LS logic chips. This is likely a PAL of some kind, as are these. So these are not really replaceable if one of these gets damaged. I think this chip right here, which is an HD 14069 UBP, this would probably be the clock chip on this board. So sometimes the damage here renders the clock inoperative, But other times, of course, it could ruin traces that go to the keyboard connector, and this over here is the keyboard microcontroller. Although those aren't too hard to figure out and you can bodge those on. But if the damage got into some of this area over here, it's going to be very difficult to try to figure out what's wrong. This is a multi-layer PCB, which makes troubleshooting that much harder. All right, I think at this point, I just need to power this thing up, give it a try, and we'll just see what happens. I mean, it may work, and there might be no damage here, or there may be problems. So I have a power supply. Let's plug it in and see what happens. I'm not going to plug any peripheral cards into this except for this, which is an ISA and PCI postcard. Not the postcard you would drop in the mail when you're sending a letter to your friend with a picture on it. This actually displays a BIOS postcode, and it will also show you the status of the voltage rails. And then this wire here plugs into the speaker head or wherever that is on here and allows you to hear the beep codes if there are any. These are very valuable tools, and at the minimum, if I start seeing codes on here, that tells us that this thing is actually booting up and trying to do something. Now I'll plug a video card in and see if it works. But we'll just stick this into a random slot like that. I have to give the manufacturer props. They silk screened on here these connections, key lock, hard drive, turbo, speaker. So that is pretty handy. My wire for the speaker is barely long enough. Like, it's really taut there. I was just checking around the board for any other markings, and I did notice I pointed out the 387 socket here, but also has a socket for a 287. So you can plug in an 8287 Mathco processor as well, which, yes, is compatible with the 386. On this end of the board here, it says copyright 1988, Rev 7.1. And that is it. There are really no manufacturer markings on here. I don't know what this is all about. Someone's taped on these little things here from the little standoffs originally. But yeah, no manufacturer markings that I can see anywhere on here. I'm about to flip the switch. Possible issues are this thing is dead and doesn't do anything at all. Another possibility are some of the tantalums on here have shorted and they will cause the power supply to not start up, or they'll blow and we'll get a little puff of smoke out of one of the tantalums. It is very common on motherboards of this age to have shorted tantalums. All right, here we go. All right, well, we got all the power rails running on here, but we don't have any postcodes at all. So that's not a good sign, unfortunately, for this thing. The motherboard has an AMI BIOS on it, and that definitely supports postcodes. Some really early motherboards like XTs don't usually support any postcodes, and this will just read dash dash, because what this does is it reads from an IO port in the address space, and that just displays the byte that's currently in that memory space. If there's nothing there, then that doesn't display anything, or if the computer's not working at all, you just get dashes like that. Let's just try one more time. Wait, okay, that's weird. Something's happening here. Let's try again. All right, we have a 0, but see, we're not getting any of the beeping out of here. So this thing is acting very strange, not normal behavior. So now we have dash dash, power this off. Now the frame LED is just stuck on. That's not normal, it should not do that. All right, so it's not working. I've tried to power cycle it a few times and it just keeps giving the dashes and no beep codes at all. So it could well be that the CPU is not working, but maybe what I need to do is just give these PLCC chips a good push, and I'll reseat all the dips in here, not the RAM. I'm not gonna do that, but at least I'll do the bigger chips. These chips labeled 1, 2, 3, 4, 5, these are definitely all PAL chips, and PAL chips like are doing some logic functions, reducing a bunch of other TTL logic into these smaller ICs. If these do go bad, or say they're in the wrong sockets, I'll have absolutely no way to know that that's the case. Like say someone took them out at one point, moved them around, it's gonna be impossible to tell that. There are no silkscreen markings to tell you like that this is the #1 chip, for instance. These PLCC chips are all very much firmly installed. All right, let's give it another try. No change at all. This LED on the bottom row on the left is the reset LED, and if I do hold down reset here with my tweezers, I do get the reset light coming on, and yet we have no activity. Let me just feel around for the temperature of these chips. These two are pretty warm. Those two aren't. Nothing is out of the ordinary here. Like nothing is super, super hot where it shouldn't be. Next on my things to try, I'm just gonna pop out the 3D6 processor out of the socket here. I have had these go bad, and then I think I have another working one. I'll pop it in and just, we'll see. We'll rule that out very quickly if there's a problem. There's the 386 processor. Came out very nicely. None of these pins are catastrophically bent. Definitely some are bent. So this processor's been out of this motherboard before. It just hasn't been installed in here forever. In fact, I'm noticing that this is a Dash 16. Looking over here at the crystal oscillators, this one here, which is most likely the one for the CPU because it's in a socket, is a 40 megahertz crystal, which probably means that this thing runs at 20 megahertz. It says 20 megahertz right now. So perhaps this processor is just not fast enough to actually work in here. Here's another processor to try in here, a 20 megahertz one. For installing the processor, there's a 1 right there and a notch drawn on the silkscreen marking. See that angle there? Matches up to the angle that's right here on the chip. It's always important to check the pins to make sure none are bent. May as well give it a little deoxit here on the socket. Why not? And you just carefully line it up. Make sure everything is in there firmly. Give it a push. There we go. Okay, here we go with the 20 megahertz chip. No change. No change at all. All right, at this point, since I'm not getting any activity on the postcard, except for those weird glitchy things initially, I'm gonna start probing around looking for traces here where the battery leaked, see if anything looks damaged, and perhaps use some bodge wire to bodge over those. Since any damage that might be on the board here will be tiny, tiny, tiny things, it'll be hard to see, I'll need to use something like this to really closely look. When you're looking for bad traces, when you have battery damage like this or capacitor damage, you just have to kind of look with your eyes and go through all of the traces and all of the vias that are in the general vicinity with your multimeter on continuity mode. You will need to scrape away solder mask because there will be vias and traces that run underneath other components. Unless you want to remove them all, scrape away a little bit of solder mask, then you can probe that, but don't forget to cover it up later with some lacquer. Okay, I think I found 3 problems. Right here, there's a capacitor and a resistor that go to a via, and it doesn't seem to be continuity between the capacitor and the resistor. There's continuity between those two, but the via right there, there is no continuity. Ooh, on the back side of the board, I put some markings with Sharpie, but when I sprayed alcohol on the other side to clean up what I was scraping away, it washed away the Sharpie. There were 2 vias here that are bad. I think it's that one right there and that one right there. So definitely from there to the other side where this via goes to, there's no continuity. So I'm gonna need to run a bodge from whatever the component is on the other side here to whatever this via connects to on the other side. There actually is continuity on the other side of this via. There's a couple components connected to it. There's continuity there, but there's a break in the via itself. I think it had too much crusty in it. And then this is the via here that connects to those multiple components. That should be easy to fix. I could just do it from this side of the board. So this via here goes to this pin on this PLCC, and that via should be having continuity with these 2 pins right here, and it doesn't. So what I'm gonna do is I'll put a bodge wire from here to there, and hopefully that should complete that circuit. And the other via I identified on the other side that seems broken is this via right here, which goes between that via there is continuity, and something underneath this ISA socket. It's flipping it over, it's this via here goes up to that pin there and that pin there. This pin here is a resistor here to here. So it's this part of this resistor right here. I'm just gonna draw with the Sharpie. So it's that pin there needs to go over to right here. I scraped off some of the solder mask. I'm gonna attach the bodge wire directly onto the trace. It's not ideal, but with enough flux, that should do the trick. It's not pretty, but I think those bodges are done. There's the one on the bottom, and there's this one on the top that should hopefully correct the 2 traces that I found that were not working. Of course, it doesn't mean that this motherboard's gonna work, but it gives it a fighting chance. One of those signals actually went to the ISA slots. I said it went to a VIA, but actually went to 10 pins up from this end. So that might be important as well. And the other one definitely talked to one of these PLCC chips. So that could prevent the computer from starting. Who knows? On the other hand, it might actually mean nothing. And those had nothing to do with the fact that this thing wasn't starting. You just don't know when you work on stuff like this. Because this computer, I don't know if it ever worked. Maybe it had been faulty from the very beginning, way before the battery leaked. Maybe that's why it was taken out of service. Anything is possible, right? So I could be chasing bad traces when the reality is there's no chance of fixing this computer because, say, one of the chipset main PLCCs here is bad. We know that the CPU is not likely bad, but it could be many other faults. So the postcard is in. I have the power supply hooked up. Here we go. No change. That is lame. I'll just do a reset here. And we got nothing. A big fat nothing. Now there is a possibility that this BIOS doesn't support postcodes. Maybe I should have tried a video card. Oh, we're getting that glitchy thing again. There's no way this computer is working properly when it's doing stuff like that, this flickering. Let me hit reset. So I hit reset, it freezes it. So it goes to 0. Well, okay, 83. Yeah, no good. No good at all. Okay, I think at this point, I am just gonna plug a video card in here just for fun, just to see if that does anything. I have extremely low expectations that this is gonna work. Here's a VGA card. It's an 8-bit card, but it'll do the trick. And we'll put this in here. I gotta prop the motherboard up since to get the card all the way in, you gotta do that. I'm gonna take some mouse pads here and stick it underneath the motherboard just so it raises it off the table so the card won't just pop out. Why don't we just plug the postcard in here for fun anyways. VGA card, monitors on the right input. Here we go. Yeah, we're getting nothing. There's no way that this thing is actually working. No way in hell. Nope, that's definitely no image, no functioning. Nothing came up on the screen at all. There's one more thing I'm gonna try before I completely give up. I'm just gonna flip this over. I am just gonna probe the output of the crystal oscillators that are over here in this part of the motherboard, just to make sure that I'm actually getting regular clock signals. Because definitely if that 40 megahertz crystal is bad, then the computer also won't work. It's a possibility. It's unlikely, but it's possible. All right, the 40 megahertz crystal is putting out 40 megahertz. This one is putting out 16, which is what it should be. And this one's putting out 40, and that's what that should be. So crystal oscillators definitely are doing their job. For one last test, the logic probe is out. I have it hooked up to the power supply on 5 volts. Let's see if this is working. So I'm gonna probe around on these EEPROMs, check through the address lines and data lines, and we're gonna look for any kind of pulsing. If there's any signs of life on this computer that's actually running at all, we should have some up and downs going on these. If we have nothing on any of these signals, that means this computer is halted and it's simply not running at all. Nothing there, nothing there, nothing, nothing, nothing. Wow. That's just high. High, high, low, high, high, high. These are all high or nothing. No activity at all. Let's just check the coprocessor socket. Yeah, this computer is not running at all, not a little bit. All right, well, I think at this point I'm gonna call it on this motherboard. The fact that there is no activity on anything at all on here just leads me to believe there's probably an issue with the chipset or one of these PAL chips as well. Maybe the PAL chips are in the wrong order. If you have a picture of this motherboard that works, and the stickers are clearly visible, perhaps I can put them in the right order if someone had shuffled them around. That is possible. But even if the RAM were bad, we would see bus activity as it was trying to do stuff on the RAM. This thing appears completely dead. I'll take a photo of the motherboard and I'll dump the BIOSes. If anyone wants that, I'll put it up on archive.org with the photograph. All right, we have the next motherboard here. This is the 286 here. Taking a closer look at this, it seems to have 1 meg of RAM, although the brand is a little mixed up. Not all the chips are the same. We have a 286 processor PLCC, and it's a 10 megahertz variant. Down here is a 20 megahertz crystal, and it is soldered into the board, so that's not easily changeable. That's what controls the speed of that processor. We have a VLSI chipset, VL82C 103, 102, 101, 104. So it's probably called the VL82C100 chipset, perhaps. All of these chips here replicate all of those ICs that were on the original IBM 5170 board. Up here's a clock chip, there's the keyboard controller, we have the ISA slots, and we have the BIOS chips, which say DTK on the sticker. So it's a pretty unremarkable board. Oh, and I see there's a brand name right there. I didn't see it originally. There it is, DTK Mini 286, made in Taiwan. DTK, they were a pretty prolific manufacturer. They made lots of machines. They had their branding on the outside of the case as well. In fact, I think I worked on a DTK computer once before on the channel, now I think about it. It has been my experience that 286 BIOS chips are interchangeable between all the motherboards, that the chipsets on these early boards essentially were a total replica of the IBM 5170 to a T. So for the most part, the BIOS chips always generally work and are interchangeable. Probably not always, but it generally does work. So if you have a machine that has a limited BIOS, try swapping it with a BIOS from a different 286, and in all likelihood, it's going to work. You don't need to worry about the fact that the chipset is different. Now this motherboard as well had battery leakage right here, is where the Varda cylindrical battery was. Some of the traces aren't looking so good. I already did some of the scraping on here. It's not terrible though. I haven't done any continuity checks though, so I have no idea if there's any broken traces here, but I think let's just give it a try and see what happens. Postcard is in, no video card. Oh, let's hook up the speaker. And here we go. Oh, we got a beep. It does just say FF though. Oh, here we go. It's changing. So I'd say that this thing is actually working. Hey, look at that. It ended up on 00. Now postcodes, the numbers you see on here aren't, okay, it's clearly working because we got another beep there. The postcodes you see there aren't universal from one BIOS to another. There are websites you can look up to see the codes, and this could be running through its diagnostics and just stop on a particular, I'll turn this off. It could stop on a particular number and then you go look up that code. If you have an AMI BIOS, for instance, and you turn on the computer and this stops at code like 36, you can go look up what an AMI code for 36 means, and it will tell you potentially where the issue is. Like for instance, say it's trying to initialize the video card and it's getting stuck there. Well, it might stop on whatever code it is for video card initialization, and then that'll give you a clue, then you check that. Or maybe the RAM is bad and it will say, RAM error, and that'll be the code. But this is a DTK BIOS, which is probably not theirs. They probably bought it and customized someone else's like Phoenix or AMI. And it's an early 286 BIOS, so the codes are very non-standard at this point, kind of more standardized later on. But it's definitely, this is an extremely useful tool for testing to see if a computer is working, because you don't even need working cards like a video card to know that it was working. Like I know this thing works because it was showing signs of life and it ended up on code 00, which usually on these old machines, it means it's fully operational. So video card's in, I plugged in the VGA connector, and I repositioned the camera. Sorry for the wires that are running in front of it. There's the monitor. Let me power it on. So we see AA here. Okay, the monitor just initialized there. There it is. AMI. Okay. Oh no, that's the VGA BIOS. DTK 286, RAM test 512K, floppy drive error check, keyboard error check, system memory doesn't match, run setup, display card doesn't match, run setup. Well, there's no battery in this thing, so the BIOS settings are definitely corrupted. But hey, this motherboard is actually working. It's funny that it only counted up 512K because this is 256, this is 256, and this is 64 and 64. So 640K total is what's actually on here. That's a little unusual that the BIOS didn't detect that right away. It's possible there are jumpers here. Like there's a jumper here and here. There may be a memory size set jumper that I need to set on here to get this thing fully working at 640K. I'm gonna pull this jumper off here and we're gonna see if that makes any difference. This jumper here looks like it was for turbo, like to permanently set turbo. I don't know about this jumper though. It's not labeled. Let's see if that changes anything. All right, still says 512K. There's also two jumpers here. One of them is hanging off, so let's, I don't know, I'll pop them both on, see what that does. Nope, still 512K. How about I take them both off, see what happens. All right, now it says base 512K and it sort of froze. Let's try putting the bottom one on. There aren't that many combinations when you have two jumpers. There are only 4 combinations here. No, it still says 512K. So it might be something I have to do in the BIOS. We haven't tested the keyboard if it works. I am just gonna lightly scrape over these traces that look a little sketchy and see if things look bad underneath. Sometimes it's just the solder mask that's looking a little ugly because of the battery leakage. And I think that's what the case is here. These traces all look fine. So what I'll do is I'll scrape it off and then I'll paint a little bit of lacquer over it where the solder mask has kind of gone bad. I have an HP keyboard here, AT keyboard. Let's plug this in and we'll see if this functions and we can actually get into the BIOS. I moved those wires out of the way, sorry about that. That was from the oscilloscope probe and the soldering iron from the last motherboard there we were working on. Okay, so keyboard is connected. I'm just trying to get into the BIOS. Yes, floppy drive check error, that is no problem. Press Control-Alt-Escape for BIOS. That is weird, that's very unusual. Oh, this looks super basic. System configuration 1. I have to push it on the numeric key. All right, base memory 3. Oh, I can just type it in? It didn't take it. Let's see, 256, enter. No. What the heck is going on? 3, 640. 640 and I push enter. Why does it even give us the option to type that when it doesn't take any of these options? 256. No. It doesn't even change. It just sits there doing nothing. Expansion memory. 384? Nope, doesn't like that either. Look how the date has a weird symbol in it there. I'm just gonna put something in that's correct. 1984, how about that? And I'll put 89. Okay, it took that. Coprocessor none. Let's just try the base memory now. Nope. All right, well, let's just save. Is this correct? Sure. System will restart. Let's see what it says once it reboots after going in there. Whoa, look at those flashy colors. I'm trying to go back in the BIOS. Why are you making this horrible beeping? Okay, I'm gonna unplug the speaker because who knows what happened there. This BIOS is terrible. System configuration 1. 3, base memory, 640. Hey, look, it took it. I had to fix the clock and then reboot. That's weird. Let's reboot out of here now and see if this works better. Now, because there's no battery, I can't turn the computer off and it won't save it, but it will hopefully at least survive a soft reset like it's doing right now. It still says 512K. Okay, fail. Let's try this diagnostic. What exactly is in here? Wow, this is fancy. Released by R&D department. Ooh. Please key in a 4-digit decimal number and press enter. Test times. I just want 1, I guess. System options to test. Okay, let's test the memory. Okay, testing memory. Good. Run again. No. Okay, so I have a thought. Perhaps some of this RAM is bad in the upper memory bank, and its way of saying it's bad is just not to show it at all. So why don't I pop that out and insert some different memory. Each of these RAM chips is 1 bit wide, just like on a Commodore 64, so you need a total of 16 chips to fill up the 16-bit data bus on a 286. 8 of the original chips was 64K, just like on the Commodore 64, and the new chips, 8 of them equals 256K, so I'm replacing the 128K with 512. Even with the pin straightener tool, getting these chips into the sockets is a little bit of a pain, and you kind of have to bend the pins over to get it to go into the socket. So I just installed another 512K of RAM, so now there's 1 meg total. I don't even know if this chipset supports 1 meg, which would be 640K main memory with 384 extended. But this is from 1989, so I'd hope that it can support that. It's possible that we can look up the datasheet on this chipset to see if it does or not, but let's just go for broke. Worst case, it's going to show up as 640K, or it's still stuck at 512 because of some other problem on this board. All right, power up time. There we go, and it does say 640K, excellent. Seems like one of these RAM chips was bad. So we'll go to Control-Alt-Escape for setup, and we'll do setup system configuration, expansion memory, 384. It let me type it in. Hey, the date is still 1989, so even though it was powered off for all that time and there's no battery, it saved the CMOS settings. So let's exit out of here, 9. This is correct. I don't know if this is gonna actually work and show the extended memory. It may not, but it may. It does not. Perhaps I should adjust this jumper here. Let's do that. I'll take that off, turn it off and on. It is right next to the memory, so maybe it has something to do with the RAM. Not quite sure. That did not help. I'm trying 384K again. I don't think this is gonna work. This thing seems too primitive for this to work. Still says 0K extended. I just set both jumpers on over here. I'll just go through all the configurations and see if anything detects the extended memory. Oh, actually it went back to 512K. So this is definitely memory size jumpers over here. Okay, well, good to know. I'll take both of them off, see what happens. Okay, it still says 512K. I'll set that top jumper on. And if I set for 384 in the BIOS, do we get 384 for the RAM test? We do not. Hold on a second, I was just looking up the data sheet for this when I rebooted, and now it says 640K, 384 extended, total memory, 1 megabyte. It worked. So the way the jumpers are configured, I have J15 set, and the one next to it, which is J14, is open. And over here next to the memory, I have this jumper set, which is J3. And then in the BIOS, I went and I set extended memory to 384, and I guess it magically worked. So it does support having all 256K chips in here. Although I have to say, these are 80 nanosecond chips in here I just installed, which is a waste because at 10 megahertz, it is not taking advantage of that. Now I could try, I have to look up how fast this chipset can go. It's quite possible though, we could replace the chip. Ooh, that processor's hot. Replace the crystal and bump this thing up. Now I have no idea if this supports 0 wait states, for instance. Typically on these old 286s, to control 0 wait states, it's not a setting in the BIOS, it would be a jumper on the motherboard. It's possible that this chipset supports 0 wait state though, and there is no physical jumper installed. So looking up the data sheet actually gives you a lot of insight into whether a chipset supports 0 wait states or not. On a 286, 0 wait states is a big performance boost. As I suspected, the datasheet is VL82C100. That's the way you look up the datasheet. So it's like the 101, 102, 103, 104, these chips here. Actually, there's this chip here as well. Oh, there's 100 right there. So look it up by the 100 chip. Now, according to this, 0 wait state, 80 nanosecond support at 12 megahertz chipset. So this is a 12 megahertz chipset, and it does support 0 wait states. It's the good old Stassen.org for looking up the motherboard. So this is it. This is the motherboard. You can tell it's the right one because the coprocessor socket is next to the memory, and there it is. Right here it has select 0 wait state and select 1 wait state. And when you have select 1 wait state, J8 is open. We will refer to the picture here. J8. There's J8 right there, and it is definitely open. So if I put a jumper on there, like I'll do right here, so I put that jumper on, yeah, the system is booted up, but if I turn it off and on, it should still hopefully work, because we're only running at 10 megahertz, which is being pushed a little hard at zero wait state. But let's boot this computer up and see if it works. This is 80 nanosecond RAM, which is totally fine, even for 12 megahertz, but at 10 megahertz, this 120 nanosecond RAM here is probably overclocked a little bit, but hopefully should still work okay. And the RAM configuration was right down here that shows you how to set these jumpers. What I wanted to show is that you can figure out how these jumpers work without referring back to documentation. So for booting this machine, I'm going to use this floppy controller, which was one where the BIOS chip got damaged by me. It was from the leading edge. This should work fine in here without a chip in there. The regular BIOS on the motherboard should control the floppy controller fine, and I should be able to at least boot this thing with a 1.44 meg drive. All right, let's see if the thing boots off this drive. All right, that sounds good. Stick a disk in here. Of course, it's complaining about the wrong media type. Yes, that is correct, because it's probably set for like a 360K drive or something. Control-Alt-Escape. Yes, diskette drive. A is none, even though it's seeked. 4. All right, so I have the old Landmark Speed 600 on here. Terrible test, but it's good enough just to test things like if the wait states are effective. Okay, so currently we're at 1 meg of total memory and 0 wait states. Let's see how fast this shows the CPU running. Oh, yeah, the VGA test will be slow, 8-bit card. All right, 10 megahertz clock speed, but it's running at an equivalent of a 14 megahertz, and that is the 0 wait states. If I switch this to 1 wait state, I bet you this will be much closer to 10 megahertz. And that's because the original PCAT, it ran at 1 wait state all the time, and there was no way for you to speed that up. So I'm just changing the jumper to set that to 1 wait state, and let's boot this back up and check out the performance. All right, here we go. What does 1 wait state do in Landmark speed test? There we go, down to 11 megahertz. So it's a definite decrease in performance. Let's see if I can run something else benchmark-wise so we can see if anything else affects that speed here. What else do I have on here? Do I have Checkit? I have Checkit on here. Let's see if Checkit actually is functional, has the OVL file. Okay, cool. That means I can actually run the system benchmarks on here with Checkit. Benchmarks, main system, and this is with running at 1 wait state. We got 1,889 dry stones and 37,000 wet stones, 1889 and 37. I'm gonna turn this off, quickly switch this jumper back to 1 wait state, turn it back on. Okay, benchmarks are running again at 0. Oh, right, we went from 1889 to 2368 dry stones. So again, a pretty sizable increase. Setting your machine to 0 wait state, if you have a 286, it really makes a difference. Oh, and from 37,000 wet stones to 46,000 wet stones. We're talking pretty sizable increase by literally just setting a jumper. Now, as I mentioned before, it's probably pushing this 120 nanosecond RAM to the limit. It's interesting that these 120 nanosecond RAM is warm. It's not hot, but it's definitely warm to the touch. It's being pushed. It could just be because of this old process. This 80 nanosecond RAM, on the other hand, it's cold to the touch. It's like it's not even doing anything. But this RAM, yeah, that's definitely warm. Anyhow, 0 wait states, excellent performance improvement. Highly recommended. Yes, the memory checks passed, so 0 wait states is working. Okay, I have one more thing I want to try. This motherboard I can't get working. Let's just try these BIOS chips on the 286 and see if it works. Why not? What's the worst that's gonna happen? Here are the 2 chips, and it's either just gonna not work at all, like it'll crash. Now, the reason why there are 2 chips is because it's a 16-bit bus, and with 16 bits, we have the high byte and the low byte that makes up one, word, I think it's called? So you need 2 chips. Now, theoretically, a 386 actually could use a 32-bit BIOS, but I guess they run the BIOS at 16-bit, which is slower, hence that shadow RAM, or caching the BIOS, takes a copy of this and puts it into 32-bit memory, and you get a big speed improvement. All right, so those chips are in. I have them in the same orientation as they were on the other motherboard. I might have to swap them around It could be that the high and the low is in the opposite sockets on the other motherboard. It may not work at all, but let's just see what happens. Okay, on the postcard, we just have dashes. We have absolutely nothing happening. So I'm gonna swap these around. It could easily be that these are just trying to initialize parts of the chipset that just don't exist, because they are, they are made for a 386, but you never know. It's just worth, I don't know, I thought it'd be fun to try. Okay, chips are both in, here we go. Okay, we actually have postcodes. We actually have postcodes. It's stuck at 14. So it started initializing the processor, and who knows, maybe it tried to do something in 32-bit and it's failed. Yeah, it stopped at 14. And so that means these BIOS chips are working because it's actually counting up. There, 3, 14, and then yeah, it stops at 14. So these are definitely functional chips. So that's not why the other motherboard wasn't working. So will a 386 BIOS work on a 286 board? Well, sort of, but not quite. It started to boot and then it froze up. And we should have normal operation. It starts at FF. This thing has weird postcodes. Doesn't quite work. Yeah, I can see activity on there, and there we go, on the screen. It popped up and there's the floppy drive seek. So yeah, everything is back to normal again. So anyways, that was a fun experiment. Well, that's gonna be it for this video. You win sometimes and you lose sometimes. I couldn't fix this 386DX motherboard. I don't know what's wrong with it, but you know what? It's got lots of spare parts on it, including all this RAM, 8 megabytes of DIP memory. And of course the 386 and 2 working EEPROMs as well, which I can salvage. Not to mention the rest of these parts, who knows, I could use them in something else. I toss stuff like this into my spare parts bin for future harvesting of parts. The 286 motherboard, on the other hand, well, it worked even though the battery had leaked, but the RAM was bad, so switching the RAM out, of course, fixed it, and 0 wait states made this thing really fly. This thing is working better than it ever did. So I hope you liked this video. If you did, I'd appreciate a thumbs up, but if you didn't, you know what to do, all that YouTube-y stuff, subscribe, etc., and that's gonna be it. Stay healthy, stay safe, and I'll see you next time. Goodbye.